Let's dive into the event-driven architecture pattern. The primary purpose of this pattern is to enable loosely coupled, scalable, and responsive systems that can react to changes in real time. It aims to improve system flexibility, scalability, and fault tolerance by allowing components to communicate asynchronously through events. An event-driven architecture is built on the idea of producing, detecting, consuming, and reacting to events. An event represents a significant change in state or an important occurrence within a system. More precisely, event producers generate events when something notable happens. These events are transmitted through an event channel or message broker. The event consumers subscribe to relevant events and react accordingly. This approach allows for decoupled systems where components don't need direct knowledge of each other, promoting modularity and easier system evolution. On the other hand, there are a few challenges to be aware of. First, as systems evolve, managing and versioning event schemas can become complex. This pattern often relies on eventual consistency, which can be challenging to handle in certain use cases requiring immediate consistency. Another challenge is ensuring the correct order of events, especially in distributed systems. This can be very difficult. Next is to overuse of events. Indeed, not every interaction needs to be event-driven. Don't unnecessarily increase complexity by only considering events as your mean to integrate your microservices. A common mistake with this pattern is to fail to establish standard event formats. Across the organization can lead to integration difficulties. Another mistake is to ignore persisting important events, which can result in critical data loss and system inconsistencies. Finally, the last two common mistakes can apply to all patterns: failing to implement proper error handling and not considering the ability to debugging issues in a distributed system. If you cannot trace your events, it'll be complex to troubleshoot your system. Okay, let's now apply EDA to our e-commerce solution. Let's front our services with a message broker. And let's consider the scenario that an end user places an order via the shopping cart. The shopping cart service will send a notification to the message broker asking for getting the product information currently in the cart. The product service subscribing to the Get Product Info message will act and respond to the request, publishing a product info message for the shopping cart to consume. The shopping cart will then want to confirm the quantity and, once confirmed, create the order. Pretty cool, right? Now, in AWS, you can implement this pattern using Amazon Event Bridge or Amazon Simple Notification Service and Simple Queue Service. Google Cloud offers similar options with Cloud Pub, Sub, and Cloud Functions to process the events. And Azure provides the Azure Event Grid, Azure Service Bus, and Azure Functions. Okay, that's all for today. Hit the like button, subscribe, and I'll see you soon.